EE World, I'm Martin Rowe. We are at APEC 2024 in Long Beach, California. We're in the TeledyneLeCroy booth, and Jonathan Schechter is going to explain to us about this test setup here for double pulse testing of silicon carbide and GaN devices. So Jonathan, why don't you explain how this test setup works?
All right, Martin, so right here we have a complete solution for double pulse testing, which is a test used for device characterization of silicon carbide and gallium nitride devices. So the complete solution that I'm talking about here is we have the oscilloscope, we have probes for all the measurements that you need to make for this test, and we have software to tie it all together to make all of the measurements needed for double pulse testing.
So, okay, yep. So why don't you tell us what are these signals we're looking at?
So we're looking at three signals here. We have a VDS signal, ID signal, and VGS signal.
Okay.
Our VDS signal is our drain to source voltage. This is our drain current, and then we have the VGS, which is the gate to source voltage. The gate to source voltage is relatively difficult measurement to make, especially when you have you're making measurements on a high side device. This is because as your devices are switching in double pulse testing, you have your high side VGS referenced to either 0 volts or the DC bus. So you have a floating measurement that you have to make, where you have a very small voltage that you have to measure, typically sitting on a significantly higher voltage.
Right.
So you can't just select any probe for this sort of testing. So we have an optically isolated probe here, where it is able to make floating measurements by optically isolating the measurement right here, up to 1 gigahertz of bandwidth, and very flexible tips for hard to reach places on your DUT. So right here we have a full 40 volt tip.
Okay.
I could direct your attention over here. We have a variety of different tips that you could use that go up to, you can see that, 2.5 kV. Very flexible and easy to use. Very high bandwidth.
Yes, it is.
And really ideal for wide band gap switching at these higher frequencies. And we're seeing it at higher and higher voltages. This is really the ideal probe for those measurements.
So in this case, the probe is attached, is just making electrical contact to the board, or how's that working? What's going on in there?
So this is a different probe that we're looking at. This is a high common mode differential probe, and this is attached via square pin headers.
I see.
Yeah.
Okay.
And this one right here is MMCX connection. But for this probe, we have an accessories kit that you can select a bunch of different connections to make with this probe as well.
Now, what kind of switching frequencies are we looking at here?
Switching frequencies can be in the tens of megahertz, but when you're making switching measurements, you need a lot more frequency content. What we're seeing for
right.
So for GaN, we're seeing 1 gigahertz a lot of times.
1 gigahertz bandwidth scopes.
Correct.
Okay.
Yeah.
Okay. And okay, very good. Thank you.
Thank you, Martin.